So, okay. Okay, I told you the area, volume, trigonometry and coordinate geometry maths lessons. Maths lessons and measuring instrument, force, work energy power, mechanical properties of matters, rotational motion and heat. They all, what's a group? All are physics lessons. එතකොට අපි කරලා තියෙනවා physics in physics part 1 2 3 4 5 6 physics lessons. 6 physics lessons. Okay, what are the remaining physics lessons? In maths part we have 1.5 lessons. In Pythagoras theorem lesson we have Pythagoras triples, like a very small session within 1 hour we can complete. We have a bulk lesson in maths part. It is statistics, descriptive statistics. That's all about maths part, mathematics part. In physics part, we have completed 1, 2, 4, 5, 6 lessons. With heat lesson, we have completed 6 lessons. Then only remain 2 lessons: fluid mechanism and electricity. Fluid mechanism and electricity. That's all. That's the full physics part. But still we didn't complete any biology lesson or any chemistry lesson. Still not started. Okay, therefore this heat lesson is a point we can move into our chemistry lessons. Actually our 10th lesson, it is thermochemistry. Actually in heat lesson we discussing about how this heat energy involved for physical changes. It is a physics lesson. But thermochemistry, our 10th lesson is thermochemistry. In thermochemistry lesson we discussing this heat energy, how involved for chemical changes, chemical variations and chemical reactions. How this heat energy involved for chemical reactions. Heat energy involved in chemical reactions and chemical variations. For chemical variations. Okay, our 11th lesson, kinetic chemistry. After that we can discuss our final lesson in grade 12. It is biomolecule. Okay, that's our plan. Let's try to complete before August. Up to August in the calling, but at least if we can complete up to this level, the remaining part is very easy. The remain only industrial chemistry, natural products, environment chemistry. They are very simple and short lessons, and only theory. As bulk lessons, we have only electricity, fluid mechanism, and descriptive statistics. They are grade 13 lessons. Okay, therefore we can complete our whole syllabus with before 4 to 5 months before exam. We can complete. Your exam will be held 27 August. End of March we can complete all lessons. Therefore if you have missed any lessons, please try to cover within this April, May, June, July. Within this period, try to cover remain lessons. If any lesson missed cover. You have time now. Before August, please try to cover any missing parts. Okay. Okay, this is a tube, heat, energy, and its fundamental concept. Fundamental concept. Before start, I forgot. Before start lesson, now we have complete 8 lesson with heat lesson, 9 lessons completed. Actually 10 lessons with Pythagoras theorem, no? අපි ඇත්තටම lessons 10ක් කරලා තියෙනවා. 10 lessons. Okay, actually this is the most important part. Then මේ lessons ටික බැලුවම you can see lot of exam questions. Lot of exam questions based on this area, volume, measurement, forces, work, and actually they are the base of the syllabus. They are the very, very important lessons. The first 10 lessons. Then topic karla tiyan tika. They are the most important lesson. Therefore, now we have to start discuss past questions. මේ වගේ questions කරන්න ඕනේ දැන්. Now you can start. Now you can find past paper questions, model paper questions, and you can find area volume questions, measurement questions, and you can try yourself. ඔයාලම try කරලා බලන්න. If you have any doubt, you can ask me. Okay. Additionally, I'm going to get some additional time to discuss some past lesson questions with you, starting from next Saturday. Starting from next Saturday. Saturday 8 p.m. to 9:30. We can. It is enough, only 1.5 hours, because after August we can start our revision. In revision we have separate day. With our 3 hours, we can get additional 3 hours after August. August mean after complete 2026 A level, we can start our revision with you have a separate program for you. You have each month you have exam and you have a special program. Okay, I will explain about our revision program later. Until start revision, we can continue our question discussion class. Past lesson question discussion class on Saturday 8 p.m. Saturday 8 p.m. Okay, Saturday 8 p.m. Remember, starting from next Saturday 25th. Additionally, you can try yourself. You can find more questions in past papers. You can get all past papers. You can download, or you can get a past paper book. However, you can download and get print out. Okay, however, you have to find all past papers and mark schemes. Mark schemes don't need to get print out, no? You can use soft copies. For past papers, you should have printed copies. If not, it's difficult. Okay, there are the information. Okay, let's start our 9th lesson, heat energy. Heat energy. Okay. Do you know different energy types? Okay, in work energy lesson, I explained different energy types. What are the examples? What are the examples for energy? Energy types in Earth. Yes, heat is a one main energy type actually. Heat energy. What else? Light energy, great. Light energy. Light energy. What else? You know, Tamanat. Heat energy, light energy. Yeah, nucleic energy, electric energy, magnetic energy, nucleic energy, what else? Chemical energy, very good. Chemical energy. What else? Chemical energy. What else? In work energy lesson we discussed what's the main type? Potential energy and kinetic energy. The common name for potential and kinetic energy? Yes, mechanical energy. Very good. Mechanical energy. Okay, they are the different types of energy types. Mechanical energy. Mechanical energy. Different types of energy types. Among them, if I told the main energy type is the heat. Why? What is the main energy source of our earth? What is the main energy source? Sun. Yes, the sun is the main energy source. I think it is sun. And this is our earth. This is our earth. This is our earth. Sun to earth, heat transfer by, we call electromagnetic waves. As electromagnetic waves, I will explain about these electromagnetic waves in the final part of heat lesson, in heat transformation part. Heat transformation part. Okay, that we call as EM waves, electromagnetic wave, that we call as heat radiation. Heat radiation. Heat radiation. As electromagnetic waves, EM waves. Okay. Now, sun to earth, heat transfer by electromagnetic wave. Actually, the main energy source transfer to the earth, heat. Okay, then what happened to these plants? Actually, the plants and different objects on this earth, what happened? They absorb heat energy. They absorb heat, actually heat with light. Heat energy plus light energy. Heat energy plus light energy. Heat energy plus light energy. These plants absorb, and what they doing? They doing their food production process. The food production process we called as photosynthesis. Photosynthesis. Using this sunlight, they doing their chemical reactions that we called as photosynthesis. Okay, using heat energy, any material, any object doing chemical reaction, then what happened? Then what happened? Heat energy transfer to which energy? Heat energy transfer, heat energy convert, not transfer, convert. Heat energy convert into chemical energy. Yes, this heat energy. Now, what happened? The light and heat energy, that means sun rays, sun energy absorbed by plants, and they doing their chemical reactions and their metabolic activities, the respiration and their food production process. Food production process. In these chemical reactions, respiration, photosynthesis, like chemical reactions, what happened? Heat energy convert into chemical energy. Chemical energy during their chemical reactions. Chemical reactions. Next, what we doing? And different animals on this earth, what they doing? They depend on plant material, no? They eating. They depend on plant material. Then what happened? This chemical energy transfer to animals. Animals like us. Okay, therefore, you can see all organisms on earth, plant, animal, microorganism, all organism depend and using this sun energy finally. අපි අවසානටම හොයාගෙන ගියොත් we also depend as foods. As foods, we getting sun energy. No, sun energy එක තමයි අපි ගන්න. Energy of the sun. Energy of the sun. Energy of the sun. Okay, finally, this dead plant material, dead animal material, dead plant material and animal material collect in the earth, enter to earth and collection. They are that we call as accumulation. Accumulate. Accumulation. In accumulation, what happened? In the accumulation, that we called as after more than million years. After more than million years, we called as fossil fuels. Then as fossil fuel also store which energy? Sun's energy. Energy of the sun. Could you understand? Again, entire world, is it remain different energy type? Light energy, electric energy, magnetic energy, nucleic energy, chemical energy, mechanical energy. All energy types starting from sun. Starting from heat energy actually. Starting from heat energy actually. I got understood, Dulen? Okay, what you need to understand, all energy types are starting from where? From the sun's energy. Actually, from heat energy. The heat is a main energy source, main energy type in the earth. The heat is the most important. That's why I told the heat is the most important energy type in the earth. I got Tirna? With me? Dule? Okay. Now, other energy type, electric energy, magnetic energy, nucleic energy, and mechanical energy, chemical energy, we can discuss in different lessons, in future lessons. Actually, about light energy, we not going to discuss in our SFT syllabus. Light energy, light energy, you learning in all level, right? Light reflection, different types. Okay, make a electric energy and magnetic energy we can discuss in electricity lesson. Nucleic energy in biomolecule lesson. Chemical energy and mechanical energy we already discussed in the work energy power lesson. Chemical energy we can discuss in kinetic chemistry lesson. Okay. Okay, they are the different energy types. Among them, in Earth, the main energy type is the heat energy. The heat energy is a base. The main energy type, the main energy source. All energy types starting from heat energy. The heat energy come to the earth and they convert into different energy types. Okay, they are the different energy type, but all energy type, the starting type is a heat. Starting type is a heat. Okay, understand. Okay, that's a story. Okay, now we can go to the lesson. That is not the lesson, that's just a story. Okay, now the first thing you need to understand what's the meaning of this heat energy, how to form a heat energy. How to form a heat energy. Okay, if I got an example. Okay, let's take an example. Think this is a whatever metal rod. This is a metal rod. Now left side of this metal rod, left side of this metal rod, I am placed at 100 Celsius. The right side also I am going to place at 100 Celsius. Both in same temperature. Now is there any heat energy flowing through this rod? Is there any heat? Is there any heat energy flowing through this rod? Making heat එකක් යනවද කොහෙටවත්? No. No heat energy flowing through this rod. No heat flow. No heat flowing. Okay, but think this is the A side. This is the B side. Okay, I'm going to place A side at 10 Celsius and B side 100 Celsius. Now what happened? Is there any heat energy? Is there any heat energy? Yes. What do you think? Heat energy flowing from A to B or B to A? What do you think? What is the direction of heat energy? What do you think? What is the direction of heat energy? Heat energy flowing from A to B or B to A? B to A or A to B? Denul? Yes, definitely. Okay. Remember the first thing. The heat energy is a energy type which is formed due to temperature difference always. Temperature difference that we call as delta theta. Delta means difference. The heat energy is an energy type which is formed due to a temperature difference. If there are no any temperature difference, no heat energy forming. Remember that. Okay, what's the definition of heat energy first? The first point. What's the definition of heat energy? It's an energy type. The heat is an energy type which is formed due to which difference? Temperature difference. Temperature difference. If there are no any temperature difference, no heat energy formed. Okay. If you want, you can prepare a short note of this lesson. This lesson, you can prepare a very short note. Actually, within 2 to 3 pages, you can get entire lesson. It's a very easy lesson if you got a short note. Okay, now the first point, what is the meaning of the heat energy? It's an energy type which is formed due to temperature difference. Temperature difference. If there is no any temperature difference, no heat energy formed. No heat energy formed. The second point, the heat energy always transfer from higher temperature to low temperature. That's the rule. The heat energy always transfer from higher temperature to low temperature. Higher temperature to low temperature. Okay, example. You are going to open the door of AC room. AC room में का door एक open करना. Like this. Think this is a room. The inside temperature 20 Celsius, outside temperature 30 Celsius. If you open the door, What is the heat flowing direction? Inside to outside to outside to in. Outside to in always. Outside to in. Therefore, you have to remember the heat energy always flowing from high temperature to low temperature. Another example. You are going to ice cube in normal ambient temperature, ambient normal temperature. What happened? The outside temperature 30 or ambient temperature, room temperature. Normally ice temperature minus 10 wage, minus 10 approximate temperature, minus 10 Celsius. Okay, what is the heat flow in direction? What's the heat flow in direction? Environment to ice or ice to environment. You met? Environment to ice or ice to environment. Yes, environment to ice. The heat absorbing actually that we call as endothermic. I will explain. That we call as an endothermic process. Heat absorbing by ice cube. Heat absorbing. That's why it is melting. Melt mean solid convert into liquid. That's a convert. That's the name is melting. I will explain in the middle of lesson. Hurry. The second point, the heat energy always flowing from high temperature to low temperature. Okay, that's the most important 2 points. Okay, what's the first point? The heat is an energy type which is formed due to a temperature difference. If there are no any temperature difference, no heat energy formed. And always, what is the heat direction? Heat always forming, heat always transfer from high temperature to low temperature. High temperature to low temperature. Hurry. You are not taken. Heat is a energy, is a form. So heat energy is a form of energy that flows due to difference in temperature between two bodies or regions. Hurry. That's the first point. It is associated with the interkinetic energy of molecule inside the matter. I will explain that later. Make a man. Okay, come to characteristic of heat energy. Heat always flowing from high temperature to low temperature. That's a always. Heat always flowing from high temperature to low temperature. The second point, now think the B side, this is a metal rod, B side at 100 Celsius and A side at 10 Celsius. Now we keep with the same temperature. If we continue this temperature difference, what happened after some time? Continuously heat energy transfer 100 side to, that means B side to A, B to A, B to A. Continuously heat transfer. Finally what happened? May I know 40 B side temperature come to 50 Celsius, approximate 50 Celsius. And A side temperature also increase up to 50 Celsius. That we called as thermal equilibrium. Thermal equilibrium. If there are any temperature difference of any substance, any two substance, it is heat continuously transfer until thermal equilibrium. Thermal equilibrium means both substance or both material or both regions come to same temperature. Come to same temperature. Come to same temperature. That we called as thermal equilibrium. Thermal equilibrium. The second point, actually third point, second point, the heat flow continues until thermal equilibrium is reached. Are you good? Thermal equilibrium means both substance or both region or both sides get same temperature. same temperature. Understood? These basic things very important to discuss the difficult advanced part in heat lesson. That's why I slowly explain. Okay. The next point. What is the unit of the heat? What is the SI unit of heat? Yes, joules. Very good. Normally, not only heat, potential energy, kinetic energy, light energy, or whatever type of energies measuring by what is the unit? Joules. Joules is the unit. Joules is the standard unit, standard international unit. Joules. Okay. Now, if any substance heated, now I have a pen or I have a metallic pen. This is a metal pen. Metal වලින් හදලා තියෙනවා. හරි? Okay, now if I heat this pen, if I heating means one side of this pen increase the temperature, right? Temperature increasing. The other side, same temperature, room temperature. Think this is my pen, metallic pen. This is my metal pen. Now I am going to heat one side of this pen. The heating side temperature gradually increasing, right? Gradually increasing, but other side is still same room temperature. Room temperature that we call as ambient temperature. Ambient temperature. Okay, while heating, what are the possibilities? The first thing, rise in temperature. Yes, temperature increasing in heating. The second one, thermal expansion. What's the meaning of this thermal expansion? Thermal expansion. What's the meaning of this thermal expansion? Okay, I will explain. Thermal expansion means, you know, thermal expansion is our first main topic. Okay, I will simply explain. Thermal expansion means with temperature, any substance heating, the temperature of this substance increasing. Temperature increasing. Do you have any idea what's the meaning of temperature? Temperature කියන්නේ මොකක්ද? Is it heat? The first question, what's the difference between temperature and heat? Is it same or difference? Tell me same or difference. I want these two words. May then same the difference. Heat and temperature. What do you think? Heat and temperature. Are they same or difference? What do you think? Dule. What do you think? Is it same or different? Completely different. Why? Completely different. Why? Heat is energy type. Heat is energy type. Okay, අද මේක තමයි පාඩම. That's a today lesson. You should have full idea what's the meaning of heat and what's the meaning of temperature and what's the difference between them. Okay, heat is a type of energy that is measured by joules. Joules is a standard unit of heat. It's a type of energy. But what are the units of heat? What is the unit of temperature? It's joules. The temperature is the unit Kelvin. What are the other units? Celsius and Fahrenheit. Kelvin, Celsius, and Fahrenheit. Are they same? No, totally different. Totally different. Okay. Okay, I will explain what is the difference. First of all, understand what's the meaning of thermal expansion. Okay, while heating any substance or any metal or whatever solid object, what happened? Their temperature increasing. The heat energy absorbed and its temperature increasing. Okay, I will explain what's the difference in next part. After the next topic, temperature. Okay, temperature increasing. With temperature, what happened? This molecule, this substance, any matter is made by molecules. No, molecules mean sodium, hydrogen, helium, different types of molecules. All materials are made by molecules. In biomolecule lesson, you can understand full idea. All materials, all substance are made by molecules. Sodium, hydrogen, helium, lithium, beryllium, different types of molecule combine and produce different substance, right? Then all substance, now think it is aluminium, then it is made by aluminium molecules. Make aluminium aluminium molecules. Okay, now what happened when it is heating? What happened to this aluminium molecule? Aluminium, a neutron, proton, electron. What happened? All these molecules with temperature increase their vibration. With their vibration, what happened? They freely vibrate. But with temperature increase, what happened? Their vibrations increasing. When increase the vibration, what happened? The intermolecule space increasing. Increase their intermolecule spaces. Intermolecule spaces mean the space between two molecules. The space between two molecules increasing. Due to that, what happened? The size of this substance increases. Actually, not size, volume of the substance. The space taken in the surround of the substance increasing. That we call as a thermal expansion. I got. Please try to get a simple idea. Further, I will explain in this relevant part. I got a high. Good. Okay. If we heat any substance, what are the possibilities? Increase the temperature, and is it possible to expand? High. Okay. Finally, after expansion, is it possible to change the physical state? Okay, change the physical state means if it is continuously heated, make up continuously heat karagen giyo. What happened? At a certain point, it's reached to the boiling point. Boiling point means the solid convert into liquid temperature. The temperature of solid convert into liquid. That we call as boiling point. Sorry, that we call as melting point. Boiling means vaporized temperature. Boiling point. Normally, water convert into water vapor at 100 Celsius. Therefore, 100 Celsius is a boiling point of water. Possible. Okay, the other possibilities. Heat energy cause changes such as rise in temperature. Yes, with heat energy increase the temperature, and it's expand in thermally expansion, increase the size of any substance, thermal expansion, and finally, is it possible to change the physical state due to melting or boiling? Okay, now I think you have very rough and normal idea. That enough. Okay, now we can discuss further part by part. Okay, now what is the meaning of this temperature? Temperature. Okay, go to the definition. The temperature is a measure of average kinetic energy of molecules. Okay, the temperature. What's the meaning of temperature? The temperature is a measure of average kinetic energy. What's the meaning of kinetic energy? The kinetic energy you already know. The kinetic energy mean in work energy lesson I explained the energy of any material or any object due to its movements. Due to its movements. Always any normally molecules in any substance, molecule of අපි substance ගත්තහම substance all solid liquid gas all made by molecules, no, all made by molecules. Okay, I will explain what are the difference. All made by molecules, solid, liquid and gas all made by molecules. Molecules, atoms, molecule atoms. Normally they have their natural kinetic energy. That means they always vibrating. දැන් මෙහෙම තියෙන්නේ. හරිද? Understand? It's a very simple story. Okay, think solid. Example, solid object. Now think it is a solid object. All solid object, not only solid, all materials, solid, liquid, gas, all made by molecules. No? Hari. Molecules වලින් තමයි හැදලා තියෙන්නේ. They are the molecules. Think it is a copper substance, then it is made by copper molecules. Okay, they are the copper molecules. They are the copper molecules. They are the copper molecules. Okay, try to get the practical idea. Harida, don't remember, don't try to only remember these definitions. Try to get practical idea. But very important. Okay, I selected solid object that is made by molecule. Liquid and gas also made by molecule. I will explain later. Okay, I selected a solid object. It is made by molecule. Normally, this molecule has a natural kinetic energy. Natural kinetic energy means they always vibrating. Vibrate pevi tama තියෙන්නේ. They always, this molecule has their natural vibration. Okay, their characteristic is they vibrating and they have their own kinetic energy due to this vibration. Due to this vibration. Okay, if we provide some heat energy for this object, now solid object, heat energy can heating, right? The substance is heating now. Now what happened? Up heat karadi. Now heat energy absorbing by this substance, right? Heat energy absorbing by this substance. This copper substance, copper solid, heat energy absorbing. Now what happened? Heat energy absorbing. Now heat energy, this absorbed heat energy convert into this molecule kinetic energy. I got this provide heat energy. Heat according to energy conservation law, energy can't be create or destroy. එතකොට මේ absorb වෙන එකට වෙන දෙයක් තියෙන්න බෑ. I got. They should have a purpose. The absorbed heat should have a purpose. It should have a direction. Oh, it should have a purpose. Okay, then what happened? This absorbed heat energy absorbed by molecules, and due to this heat energy, their kinetic energy increasing. Their kinetic energy increasing means their vibrations increasing. Why? Due to this provide heat energy. That we called as a temperature increase. That we called as a temperature increase. Hari. තව example ඒක මම මේ විදිහට කියන්නම්. Okay, now understand. Initially the copper temperature 10 Celsius. Initially, before heated. Before heated, the temperature of this copper plate, it is 10 Celsius. Now these copper molecules vibrating like this. Copper molecules vibrating like this. Now vibrating like this. Now if we heat it, 5 minutes heated, 5 minutes heated. Now what happened? This heat energy absorbed by molecules and their kinetic energy increasing. Their vibration increasing. Molecule vibration is increasing like this. Vibrate, then wake. Due to this average kinetic energy increase, their temperature also getting increased up to 40 Celsius like this. Okay, that's why I told the temperature is a measure of average kinetic energy of molecule in a substance. I got now? Understood? The temperature is a measure of average kinetic energy. That means measure of vibration. Measure of vibration. If it is very low vibration, it has very low temperature. If it has high vibration rate, it has a high temperature value. Do then got? Okay, the temperature is a measure of vibration. Measure of vibration or measure of kinetic energy of molecule of any substance. Measure of hurry. Now I told five very important points. What's the meaning of heat? Heat is a type of energy due to temperature difference. Second point, heat always transfer from high temperature to low temperature. High temperature to low temperature. What's the unit of heat? Joules. What's the unit of heat? Joule. Fourth one. What's the fourth one? Due to temperature, what are the possibilities? Increase the temperature, due to absorb heat energy of any substance. They are the possibilities. I think now you have idea. One of the possibilities, increase the temperature. Temperature increasing mean increase kinetic energy, right? Increase molecule kinetic energy. Increase molecule kinetic energy. Then what are the other possibilities? Thermal expansion. Due to this kinetic energy, what happened? Intermolecular space increasing. Therefore, increase the size. Finally, change the physical state. Okay, change the physical state එකත් ඒකෙම step එකක් තමයි. I will explain in second part. Yes, wait. Okay, final point, fifth point, you have to remember that what is the meaning of the temperature? The temperature is a measure of average kinetic energy of molecule of any substance. Remember these all definitions. Actually, all definitions of this lesson very important. Scales of temperature, Celsius is the mostly used one, frequently used one, but Celsius is not the SI unit. Kelvin is the SI unit. Mark this. Kelvin is the SI unit of temperature. Kelvin is the SI unit. Additionally, we can use Fahrenheit. Fahrenheit. Okay, the relationship also given. They are not asking normally. Kelvin temperature equals Celsius plus 273. That's for additional knowledge. Any Celsius you can convert into Kelvin by adding 273. That you did in O level, right? O level. Okay, the same thing explained here. Effect of heat on matter. Okay, when something heated, what are the changes, inside changes? Okay, the same thing. When heat is absorbed by any matter, what are the molecule responses? Molecules move faster. Molecules move faster mean vibration. හරි මෙතන clearly දීලා තියෙනවා. Increase of kinetic energy of molecule. Yes, kinetic energy increases. Great. Third one, vibrations increasing in solid. Finally, their intermolecule spaces increasing. Increase their intermolecule spaces. Increase their intermolecule spaces. Due to this changes, what are the observable? Normally we can't these internal molecule vibrations we can't observe, but they are the observable changes, observable effects. We can see due to this increased kinetic energy of molecule, what happened? Temperature increasing. We can observe if we measure temperature by any thermometer, we can see increase the temperature. We can't see molecule vibrations, but we can decide this molecule vibration according to the temperature. Okay, temperature increasing means their molecule vibrations increasing. Understood? Okay, then expansion. Due to these intermolecule spaces increasing, increase their intermolecule spaces. That means intermolecule spaces mean the distance between two or more molecules. The distance, minimum spaces. When increase, what happened? Start to thermal expansion. That's the story. That's the thermal expansion. Finally, it is possible to change the physical state. Change the physical state. This physical state change I will explain completely in second part of lesson. Okay. Finally, temperature measuring devices. They are not important. Mercury glass thermometers, alcohol glass thermometers, digital thermometers, thermocouples, infrared thermometers, and they are the different types of thermometers. No? Okay, they are not asking no. Okay, that's for additional one. Okay. Okay, that's the base of heat lesson. That's the base of heat lesson. Now we are going to start our first part of heat lesson. Do you have any doubt up to now? You can ask now. If you have any doubt up to now, you can ask now. I'll give you 1 minute. Any doubt? Okay. If you know doubts, now we can start the lesson. Actually, this is the point we are going to start the lesson. The previous part, very basic things we discussed. Now, in heat lesson, this heat energy lesson, we can classify it into three main areas, three main sections for easy understand. The first one is the thermal expansion. Okay, today we are going to discuss thermal expansion. thermal expansion. Thermal expansion. Thermal expansion. Our second topic is a second main topic. Second main topic. Today we can't start this. Other make a battery way. Quantity of heat. Quantity of heat. Quantity of heat. Final part you already know. Thermal transformation. Thermal transformation. Thermal transformation. That means transfer. Thermal transfer. Conduction, convection, and radiation. We have calculations as well. In O level, as I remember, you did conduction, convection, radiation only definitions without calculations. No calculations correct? Am I correct? In O level, you didn't calculate thermal conduction rate. No. Okay, in this lesson, we are going to discuss these calculations as well. Okay, before that, we can start now our first lesson, first part, thermal expansion. Thermal expansion is the first part. Thermal expansion is the first part. If you want, you can prepare a very short, small short note. Short note of Hadar. Then it is easy to remember this basic concept. Okay, now you already know what's the meaning of thermal expansion. Thermal expansion. Thermal expansion. Okay, what's the meaning of thermal expansion? Increase in size with temperature. With temperature. That's actually thermal expansion. Come to the definition. Thermal expansion is the increase in length, area, or volume of matter when its temperature increases. Yes, this is the definition. In other form, we can say increase the space taken in the surrounding with temperature increase of any matter. That's the thermal expansion. Increase the space taken in the surrounding. You can space එක ගන්න එක වැඩි වෙනවා. That means simply increase the size of any matter with temperature increases. Okay, that's the thermal expansion. Thermal expansion. Okay, what are the reason for this thermal expansion? Now you already know. What happened? Due to heat absorption, see, at normal temperature, they are the molecules. They are compacted and very low amount of kinetic energy. Very low kinetic energy, they already compacted. But when heated, this heat energy absorbed and this heat energy convert into molecule kinetic energy. Heat energy convert into molecule kinetic energy and their movements, their vibrations increasing. Due to their high vibrations, what happened? Molecule kinetic energy increasing. Due to this intermolecule bonds, due to this molecule kinetic energy, their intermolecule bonds increasing. Intermolecule spaces. Intermolecule spaces increasing. See, they are the intermolecule spaces. The spaces between molecules. Intermolecule spaces increasing. Due to that, the size of object is increasing, or the volume of object is increasing. I got this because heating, increase molecule vibration, increase average separation between molecules. And write down here within bracket, increase intermolecule spaces between molecules. Okay, that's the actual reasoning. The same thing given, but it's more clear. Increase intermolecular spaces between molecule. Clear? Okay, up to now, okay. Uh, Previous page mean this one. Okay. Okay, no doubt up to now, right? Great. Okay. Now what we discussed, what's the meaning of thermal expansion? The thermal expansion is due to heat energy absorbed, their molecule kinetic energy increasing. This heat energy convert into kinetic energy. Yeah? According to energy conservation law, heat cannot be created or destroyed. That you already know. Therefore, heat energy, this absorbed heat energy convert into molecule kinetic energy. Due to this molecule kinetic energy, their vibrations increasing. Due to their vibrations, molecule intermolecule spaces, the spaces between molecules increasing. That's why the size of any substance is increasing. That's the meaning of thermal expansion. Now, substance or matters, mainly three types. No, matters mainly three types. What are they? Solid, liquid, and gas. Matters mainly three types: solid, liquid, and gases. Solid, liquid, and gases. Okay, you know all matters made by molecules. Now you already know all matters: solid, liquid, and gases. As example, take copper. Copper is made by copper molecule. Aluminium is made by aluminium molecule. Zinc is made by zinc molecule. What else? Oxygen gas. Oxygen gas is made by oxygen molecule. Ozone gas is made by oxygen molecule. Carbon dioxide gas is made by carbon and oxygen molecules, right? H2O, water is made by hydrogen and oxygen. I got all matters, liquid, gas, and solids. All matters are made by molecules. Understood? Molecules. Now, but their molecule mechanism is different. Molecule mechanism is different. Molecule mechanism is different. Their molecule mechanism is different. Okay, what's the difference? If you got solid, see, this is a solid molecule formation. They have very strong intermolecule bonds. Okay, what are the meaning of intermolecule bonds? Intermolecule bonds mean the bonds between these molecules. Bonds between these molecules is very strong, and they are molecule kinetic energy very low. They are very compacted, highly compacted like this. Molecules are highly compacted like this. Therefore, their vibration ability very limited, and they have very strong intermolecule bonds. Good. And may I kata karana ice kena? If you got water, it is ice stage. They have very compacted molecules and they have huge intermolecule bonds, more strong intermolecule bonds, and low molecule space. Yes, low intermolecule space. You can see here. Very low intermolecule space. They are highly compacted. Then what you think? Their expansion ability, it's high or low. The solid gattaham, their solid expansion ability comparatively high or low. Liquid and gases ek balwa. If you compare with liquid and gases, very low because they have huge barriers, intermolecule bonds. bonds, and they are compacted. They are compacted. Therefore, when heated, while heated, their vibration ability very limited. Very limited. Therefore, their expansion ability is least very low. Very low. Hurry. If you got liquid, this is a liquid. This is a liquid. They also compacted, but they have more spaces than solid. May water, liquid water. They have spaces, but still they are compacted. Sorry. Yeah, still these molecules compacted, but they have medium level intermolecular bonds. Medium level, not more strong than solid, more strong like solid. They have medium level intermolecular bonds, and their intermolecular spaces also medium. See, understand the difference? Get the difference? Medium, or everything medium. See, medium intermolecular bonds and moderate expansion ability. Moderate expansion ability. If you got gases also made by molecules. Gases also made by molecules, but they have very weak intermolecular bonds. Very weak intermolecular bonds. And they are freely available with high intermolecular spaces. They have huge intermolecular spaces. They are the spaces. They are spaces. They are the spaces. Very weak intermolecular bonds and very large intermolecular spaces, gaps. And how about their expansion ability, gas expansion ability? How about gas expansion ability? How about gas expansion ability? Yes, comparatively greater than liquid and solids, because they have very weak intermolecular bonds. Very weak intermolecular bonds. Therefore, easily they are vibrations, right? They vibrate, increasing their molecule kinetic energy very easy, because they don't have barriers, right? They have enough space, and their intermolecular bonds very weak. Okay, I got solid, liquid, and gas differences. Understood? Okay, do you know? මෙහෙම අපි ගත්තොත්, if you got a balloon filled with gas, මේක balloon එකක්, balloon filled with gases, not a fish, it's a balloon filled with gases. If I heat this, what happened? මේක අපි චුට්ටක් රත් කරොත්, අවුවේ තිබ්බොත්, what happened to this balloon? Yes, blasting. What is the reason? Now you can understand solid and liquid gas expansion. Okay, first when it is heating, first heat the balloon, right? Balloon layer. It's a solid. It's a solid. Now first what happened? The balloon layer, that means solid layer, is expanding. Solid layer expanding. After that, this heat absorbed to the inside. Then inside air, gases heating. When gas is heating, what happened? Normally gas expanding more than solid. Gas expanding more than solid. What's the reason? They have very weak intermolecule bonds and they have more spaces. They have more chances to vibrate. But solid, it is very limited. Therefore, gases expand more than solid. Due to that, same temperature, gas expand more than solid. Due to that, the pressure occurred on this balloon layer is increasing. Pressure එක වැඩි වෙනවා. Due to that, it's blast. I got කරලා බලන්න. balloon එකක් full fill කරලා අවුව තියලා බලන්න ටිකක්. It's blasting. The reason? Expansion. Actually, the reason is the gas expansion is more than the solid expansion in the same temperature difference. Understood? Okay. Okay. Okay, that's actually the comparison. If you got solid, they have very strong intermolecule bonds and intermolecule spaces very low. The expansion ability very low. There is a strong molecular attraction. Strong molecular attraction means they are highly compacted. If you got liquid, they have medium level intermolecule bonds and medium level intermolecule spaces and expansion ability higher than solid. Yes, it is greater than solid. The reason weak bond compared to solid, weak intermolecule bond. It is not highly compacted, but they closely compacted, but not highly compacted like solid, right? If you got gas, their intermolecule bonds very weak. Therefore, the expansion ability very high due to high intermolecule spaces. Freely moving molecule with very weak intermolecule bonds, that's the reason. Hi. Okay, that's the base of thermal expansion. Any doubt? When we add more lighter gas, does it increase? Increase mean you're asking volume increase? Yes, yes. Yeah. It's not the effect. Normally the lightness of gas depend. If it is lighter than normal atmosphere, it's going up. That's okay, but expansion is same for both. Expansion is same. If we heat it, it's plus. You're asking this helium or hydrogen filled balloons, right? Yes, they also, if it is heated, plus T. Yes. Because that one also same molecule structure, more than solid, gas expansion is greater, right? Okay, now you know all materials means solid, liquid and gases, all made by molecules. Now if they all made by molecules, they all what happen, expanding, right? Solid, liquid and gas all made by molecules. So helium balloons explode when gone up after some time. Yeah, if they export to high heat condition, they will be explode. And they draft deflate solely. No, I think they have a pressure level. Normally, අපි ඒවට use කරන්නේ normal balloons නෙමෙයි. ඒවට use කරන්න ඕනේ දැන් මෙහෙම exploit වෙන්නේ නැහැ. හිතන්න. Normally, if you use a special balloon type, their maximum capacity think 200. If you only 180 air particles filled, they have more spaces. It has more spaces for expand. එහෙම තමයි ඔය balloons design කරන්නේ. They give some space. They know about expansion. They give some additional space for expansion. Then make it 200 ම fill කරලා යවුවොත් තමයි exploit වෙන්නේ. The reason the balloon can't retain this pressure variation. Okay, Dinu. Normally this is specially designed balloons. අපි උඩ යවන්න එහෙම හදන ඒවා special design කරන්නේ. They have a pressure level. Normally they filled with pressure measuring by pressure. මේ measure කරලා තමයි මේ fill කරන්නේ. Normally they maintain a free space than maximum level for expansion. That will be present. I told exploit normal balloons. අපි normal balloon එකක් ගෙනල්ලා පුම්බලා fill කරලා අවුවේ තිබ්බොත් පිපිරෙනවා ටික වෙලාව. The reason that's a maximum level. After maximum pressure, they can't retain after that. Okay, that's stored. Okay, mate. You know. Okay. Okay, now you know all materials, solid, liquid and gases, all materials are expanding. All materials made by molecules, therefore all materials are expanding. Okay. According to that, thermal expansion can be categorized into three main types. Three main types according to matter type. The first one, solid expansion. The second one, liquid expansion. Third one, gas expansion. Okay, now we have three main types of expansion: solid expansion, liquid expansion and gas expansion. solid expansion, liquid expansion, and gas expansion. Okay, this is a summary. Thermal expansion, solid expansion, liquid expansion, and gas expansion, mainly three types. Mainly three types. If you got solid expansion, again we can categorize into three types. That's very important. Solid expansion, again three types. Solid expansion, again three types. The first one, linear expansion. Linear expansion. The second one, area expansion. Final one, volume expansion. Solid expansion, how many types? Three main types: solid expansion, area expansion, and volume expansion. If you got liquid and gas expansion, it has only volume expansion. Understand? If you got this type rod, solid rod, it's a solid rod. If I heat it, make up a heat karot, we don't need to think about area or volume. Only think this type small rod, very thin rods, only think length expansion. This length expansion we called as the linear expansion. Length expansion. Only length. Only length. We not consider width. Width එක හිතන්නේ නැහැ. Only length expansion. The length expansion only valid for linear expansion only valid for linear objects. Rod වලට very thin rods and cables ඒ වගේ ඒවට තමයි ගන්න. If you got this type plate, මේ වගේ, just like plate, very thin plates. If it is heated, we don't need to think about height, right? The height we can neglect because they are very thin plates. Very thin plates. Now we can say it is area expansion. Area expansion means actually length into width. Length and width both expansion, that we call as area expansion. If you got this type 3D object, now it is 3D object. It has a length, it has a width and height. 3 dimensions. If you got this type 3D, 3-dimensional object, length, width and height, all dimensions expanding, that we called as volume expansion. But if you got liquid and gases, they have any linear expansion? අපිට liquid එක ගන්න පුළුවන් the length එකක්, the length of liquid, the area of liquid, impossible, right? Gas, the area of gas, the length of gas. Okay, that's why for gases and liquid, that we called as fluid. මේ දෙන්නටම අපි කියන fluids කියලා. Fluids. Liquid and gas both have a volume expansion. Volume expansion. Clear? Understood? Okay, let's try to complete linear expansion today. Then next week we can complete the expansion part. Solid expansion. When a solid is heated, its dimensions increase due to the molecule vibration, that you already know, called as solid expansion. Solid expansion. Solid expansion mainly 3 types: linear expansion, area expansion and volume expansion. The linear expansion we called as delta L because length increasing, right? The length changes. Length change that's why we called as delta L. The increase in the length of a solid object along one dimension when heated is known as the linear expansion. The increase in with heated while heating, the length of any solid object increase along one dimension. One dimension, only length, only length. Okay, that's the actual story. Okay, this is a initial length. This is the initial length. Okay, L1 is the initial length. Think it is L1 is the initial length. L1. While heating, what happened? While heating, when increase the temperature, it is increased up to this level. That we called as delta L. Length increase amount. Delta L. Delta L. I got that's the linear expansion with temperature increase the length. That's the linear expansion. Okay. For linear expansion, there are three main factors affect on linear expansion. There are three main factors affect on linear expansion. It is very important. Linear expansion. Okay, understand that is very important. If you can understand very simply linear expansion, area volume expansion is very simple, and liquid gas expansion also very simple. Make a theorem got that. The next week class, next week lesson will be very easy. Now, linear expansion. What's the meaning of linear expansion? Linear expansion means while increasing the temperature of any substance, think initial temperature, theta1 temperature, this is the length of any substance, length of any rod. That we called as L1, initial length. Initial length at theta1 Celsius. Theta 1 Celsius means room temperature or whatever initial temperature. Now, if it is heated up to theta 2 Celsius, if it is heated up to theta 2 Celsius, if it is heated up to theta 2 Celsius, theta 2 Celsius, the length increase up to L2. L2 is a final length. Final length. This increase amount we called as in the delta L. The delta L is a linear expansion. This delta L, increased length, is a linear expansion. I got? Clearly understand that's a very important part of the lesson. Remain parts very simple. Okay, see this. Okay, I told there are three main factors. There are three main factors affect on linear expansion, right? Three main factors. What is the first factor? Initial length. Initial length is the first factor. Three main factors affect on linear expansion. The first one is the initial length. Initial length. Very simple, right? Initial length. Initial length. You know, initial length means L1. L1. Second one, temperature difference. Temperature difference means theta 2 minus theta 1. Theta 2 minus theta 1. In short form, we can say delta theta. Delta mean difference. Delta theta. Delta mean difference. Delta theta. Final factor, material type. Matter type. Matter type. Matter type. Hi. The first thing, what you think when increase the initial length, the linear expansion value, that means delta L, increasing or decreasing? What do you think? When increasing the initial length, it can initially I got 1 meter odd and 2 meter odd. Which one has more delta L value? I got my question. Yes, 2 meter one. Now you can understand when increase the initial length, the length increasing ability, that means linear expansion, the delta L also increasing. Delta L increasing. Delta L increasing. Delta L increasing. Okay, both increasing, no, that we called as directly proportional. Delta L directly proportional to the L1. Delta L directly proportional to L1. The second point, when increase the temperature difference, what do you think? What happened to the length increasing amount? Delta L. Increasing or decreasing? Now think temperature difference 30. If I increase up to 60, it's expanding more. Yeah, increasing. More expanding. Therefore, that one also delta L directly proportional to delta theta. Temperature difference. Temperature difference. Temperature difference. Initial length directly proportional and temperature difference also directly proportional. හොඳට බලන්න. මේ බලන්න. Now, according to this relationship, we can say delta L proportional to the L1 delta theta. Delta L proportional to L1 delta theta. Delta L proportional to L1 delta theta. Okay, in physics, I want to remove this proportional mark. What I can do? මොකද කරන්නේ? I want to remove this proportional mark. Great. I want to add the, yes, we have to add the constant. Constant එකක් දාන්න වෙනවා. හරි. L1 එක දාගත්තා. L1. Okay, this is my constant that we called as alpha. Alpha. It is not the proportional mark. Alpha. Delta theta. This is our first main equation of linear expansion. Delta L equal L1 alpha delta theta. Delta L equal L1 alpha delta theta. L1 equal, sorry, delta L equal L1 alpha delta theta. Delta L equal L1 alpha delta theta. Please take a paper and write down like this clearly. It is only given equation. Delta L equal L1 alpha delta theta. Okay, if you complete, please send me a message. Please send me a message. Complete. Complete. Okay. Now, what's the meaning of delta L? What's the name of delta L? Quickly, quickly. Very important. What's the meaning of delta L? Name. The length difference or linear expansion. Yes, length difference or linear expansion or increased length. L1, 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 initial length. Delta theta, delta theta, temperature difference. Then what's the meaning of alpha? What's the meaning of alpha? What's the meaning of alpha? No, alpha is not matter type. Alpha is a constant depend on the matter type that has a special name. That has a, yes, it's a constant that has a special name, you meant, that we called as linear expansion coefficient. Linear expansion coefficient. The linear expansion coefficient alpha is a constant depend on the material type. Constant depend on the material type means we change the matter type, this value also changing. The alpha has a value. As example, copper linear expansion coefficient 5 into 10 to the power minus 6. If you got aluminium, it is 6 into 10 to the power minus 6. material to material, plastic another value, concrete another value, iron another value, wood another value, material to material, this constant will be changed. Understood? That's why I told there are three main factors affect on the linear expansion coefficient. Understood? Okay, name alpha is the linear expansion coefficient. Alpha is the linear expansion coefficient. All right. Final part of today. Final part. Final topic. In your paper, write down alpha, linear expansion coefficient. Linear expansion coefficient. Linear expansion coefficient. That means alpha. Alpha. It is not proportional. Eh? Alpha. Alpha. Okay. What is our main equation? Delta L equal L1 alpha. Sorry. L1 alpha delta theta. Now, can you isolate alpha? Or we can isolate alpha. Alpha equal delta L divided by L1 delta theta. Okay, this is a linear expansion coefficient. Now, how we can define this linear expansion coefficient? આપણે કોમાં define કરવાનું plan, how we can define the definition of linear expansion coefficient? It is very simple. It is very simple. The meaning of the definition of linear expansion coefficient, if you got any material, unit length can 1 meter. If you got copper, 1 meter copper rod, increasing the temperature by 1 degree, its linear expansion. Its linear expansion means increasing length is the linear expansion coefficient. Do you need to remember these definitions? No. Please understand this method. Always any equation dividing factors become 1. Divide whenever එකක් වෙනවා. මතකයිනේ? The velocity equal displacement divided by time. The displacement within unit time. Divide when එකක් වෙනවා. Unit එකක් වෙනවා. 1 unit. Okay. That's a rule. Then how we can define a linear expansion coefficient? The unit length of any material while heating by 1 degree Celsius, its increased length or linear expansion, its linear expansion called as linear expansion coefficient. Okay, this is alpha. Very simple. Any material unit length while increasing the temperature by 1 degree, its linear expansion. It's already given. The linear expansion coefficient, that is depend on the material type. Increase in the length of unit length. increase in length of unit length when temperature increase by 1 degree Celsius. Okay, how you can remember this? Alpha equal, please remember, please understand how to remember. No need to by heart. Delta L over L1 delta theta. Length, unit length temperature increase by 1 degree, the linear expansion is the linear expansion coefficient. I got? The linear expansion of any material while increasing the temperature by 1 degree of unit length. Unit length of this material. Unit length while increasing the temperature by 1 degree, its increased length, its linear expansion or its length difference is the alpha. Dulin, I got? Okay, final task. Final task. Final task. Oh, 11:30, no? We have another 2 minutes. Final task. Can you get the unit of linear expansion coefficient? Alpha unit. Alpha unit. Alpha unit. What's the unit of alpha? මෙයාගේ unit එක මොකක්ද? What's the unit of alpha? What's the unit of alpha? Quickly. Great. It is per Kelvin. Why? Length difference, meter. Initial length, meter. Temperature difference, standard unit, Kelvin. Meter to meter cancel. Kelvin comes up. Per Kelvin is a unit. Per Kelvin is a unit. Kelvin ऋण Kelvin -1. Per Kelvin is a unit. Per Kelvin is a unit. Okay, that's a today lesson. Please go through again and again these areas, because area expansion and volume expansion, the same thing we're doing, only letters are changing. Linear expansion coefficient in area expansion, it is beta, that we call as beta area expansion coefficient. That's only difference. In volume, it is gamma, that is volume expansion coefficient. Okay, that's only difference. The same thing we're doing again and again in other expansions as well. Okay, therefore, please go through again and again until familiar this equation. Familiar this equation, then other remain parts are very simple. Okay, do you have any doubt up to now? Okay, remain calculations we can discuss next week. Again, you have class on 25th, Saturday night. Saturday night. Again and again, 2 to 3 times you can go through, and I will send you a tute tomorrow. I'll post it tomorrow. Make it tute make them. Then Wednesday or Thursday, you can collect that and you can start work. Okay, any doubt? Met me? Then let's meet next Saturday evening, and Sunday both you have class, Saturday and Sunday. Okay, goodbye. Please go through again this equations and the family. Okay, goodbye.